Now with problem number 6, we have an integral that definitely has function composition. We have t plus 1 over t, quantity to the second power. So there's definitely function composition there, but we can't use u substitution for it because the derivative of the inside, which would be 1 minus 1 over t squared, doesn't show up on the outside. So I'm going to quickly go through this example again. If you go back to derivatives, the derivative of f of g of x, the function composition, using the chain rule would be take the derivative of the outside, leave the inside alone, times the derivative of the inside, and then we're done. So if that's true, then the reverse process of integration should say the integral of f prime of g of x times g prime of x dx should bring us back to f of g of x plus c. So what you want to do is look at the structure of this integral that we use with substitution. We have a function composition here, and it has an inside function, g of x. And the derivative of g of x, which is g prime of x, shows up as a multiplier on the outside. So that's the basic condition for the typical use of u substitution. But if you look at our problem here, we have t plus 1 over t, quantity squared. The derivative of that inside, as I said, 1 minus 1 over t squared, doesn't show up the way that g prime of x shows up over here on the outside of the function composition, multiplied by the function composition. So we can't do that. So what we're going to do instead in this case, when it's a square, is we can simply expand that out or multiply out t plus 1 over t times t plus 1 over t, and that would give us t squared. And then the t times 1 over t is going to be 1. We have two of those. Plus 1 plus t 1 over t squared, which I'll write as t to the negative second power. So we have t squared plus 2 plus t to the negative second power. And all we need to do then is find the antiderivative of each piece and evaluate it at the upper minus the lower limits. So t squared plus 2 plus t to the negative second dt. Alright, so the antiderivative of t is t to the third over 3. Then the antiderivative of 2 is 2t. And the antiderivative of t to the negative second is going to be t to the negative 1 increase divided by negative 1, or minus 1 over t. And evaluating at 2 minus evaluating it at 1. So we're definitely going to have two expressions here. And 2 to the third would be 8 over 3 plus 4 minus 1. Then we'll have 1/3 plus 2 and minus 1. So if we do a little simplifying, 8/3 plus 3 minus 1/3, and 2 minus 1 would be 1, so minus a 1 there. So 8/3 minus 1/3 is 7/3, and 3 minus 1 would be plus 2, so 7/3 plus 6/3. Hang on a second.